Hola, buenas tardes con todos y todas.
Hola, Darwin.
¿Cómo están?
Bien, muy bien. Bienvenidos a todos. Buenas tardes. Vamos a esperar dos. Hi, Ian.
Please forgive the dog.
Don't worry. Hi, Lynn. Welcome. Thanks for joining.
Hello from Arkansas, USA.
Welcome. We are going to wait some 3 or 4 minutes until everybody gets connected, and we are going to start.
That's fine. No problem.
Bueno, ya vamos a dar comienzo porque hoy tenemos un día muy ocupado, igual que ayer, así que para no perder tiempo y poder aprovechar lo máximo posible a Lynn, como todos saben, hoy nos va a acompañar Lynn Hare. Ella es partner de Globe hace muchísimos años, es de la Universidad de Arkansas y hoy nos va a acompañar en el entrenamiento de suelos y de las actividades para los grados más bajos de primaria. Así que seguramente
Bueno, mientras esperamos, a ver, ahí a Mariana me avisó que se le cortó el internet. Antes de comenzar, le aviso por las dudas a todos. Si alguno necesita traducción simultánea, acuérdense de que está disponible y pueden acceder haciendo clic en el loguito, en el icono de un globo que hay en la esquina inferior de sus pantallas de Zoom. Eso en principio. Así pueden aprovechar al máximo el entrenamiento. Y sin más, le doy la palabra a Lynn, partner de Globe, que nos va a estar entrenando en suelos esta mañana, esta tarde. Depende de dónde esté cada uno. Lynn, are you connected to the live translation?
No.
Okay, you can access the live translation by clicking on the little logo of a little globe at the bottom of your Zoom. And you can choose
Interpretation.
Yes, there.
Okay.
And there, if you choose English,
Spanish.
everything we say, yeah, will be translated.
So if I say good day, now it translates.
Yes, exactly.
Bueno. Hey, Andrea.
How are you? Nice to see you, Lynn. Welcome to the region.
And Claudia, I see you. Yeah.
Hello, yes, I saw you.
I see many people I know. I miss you all.
Me too.
We miss you too, Lynn.
Hey, Monique.
Hi, how are you? It's so good to see you.
Oh, big hugs to everybody.
Yes, thank you.
So, Lynn, I don't know if you heard me earlier, but just in case, Mariana is having some connection issues with her internet, so we're going to start directly with the training. If you're already available.
Would you like me to begin?
Yes, please.
Okay.
Thank you. I'm sorry for the technical issues.
And today we're going to be talking about past year and the importance behind soils. So these are the materials that I had asked you to have. Soil characterization, the data sheet, the texture by field chart, newspaper, or just something in front of you that would cover up the area so you don't get your desk dirty, a plate and a spoon, a misting bottle like this, or a small bowl with water that you can hold and then take the water and put on your soil sample. 2 to 3 tablespoons. Oh, I just dropped some soil. 2 to 3 tablespoons. This is just, I'm just showing you a little bit, but you don't need a whole lot of soil. And then optional, if you have a color book, and a pH paper, those are optional. So if you don't have them, that's fine. So one of the things I wanted to point out is the book Scoop on Soils. And
Sorry, Lynn, are you having any trouble with this, with the translation or something?
I did choose Spanish.
If you select the English option,
Okay.
you
Well,
are
I was
not going
in English to begin with, and then now I'm not seeing Zoom. There we are.
Yes.
So,
If not, you
hold
are
on just a
going to
second.
hear all the Spanish
So I
translation.
should be in English.
Yes.
Yes, exactly.
Yes.
And now you are not going to hear all the
Okay,
Spanish
all right.
translation.
Okay. So I am at this point. Do you need me to share? I should be sharing my screen. That's what I haven't done yet, is share my screen. So that's what I want. Share and here and sorry. All right, now do you see my screen?
Yes.
Okay.
Yes, perfectly.
Good. Okay, so we're talking today about pedosphere and pedology, pedestrian, all of that has to do with soils and the ground on which we walk. So this list of the materials that I had asked you to bring or to have ready, not too difficult to get together, I don't think, and we will be working with this in a little bit. I did want to point out the Scoop on Soils book. You probably are familiar with it, but I created a page for students to be using when the teacher is reading this book. And this I will talk a little bit more about when we look at the K4 materials that I have gotten together for you all later today. So one of the things that, one of the soil learning activities that's a lot of fun for any age group is the activity Soils in My Backyard. And so how do soils differ in my city, my town, my area, even one part of one city? Every backyard can be very different. So this would be where students would show their soil samples and just looking at the color, maybe feeling the texture, all of that would be something you could do with this activity. And this one is a lot of fun to do. Now, one of the things that you really need to do before any soils activity is done is you need to decide what the site is going to be, where the site's going to be, and then you're going to need to define it in the GLOBE data pages. And this is the activity. There are 3 ways that you can enter GLOBE data for either the PIT method. I really don't recommend this because basically you are digging 1 meter deep, 1 meter wide, and most schools do not have that much room that doesn't have electricity or computer lines or something like that that you can really mess up. And in the United States, we have to ask our local city people before we can dig. We have to get a permit. So this basically is like digging a grave. It's that big, and you need to be able to get a couple of people in it. So it's very big. It's probably 2 meters by 1 meter by 1 meter. And that's just too difficult to do. But if there's an area on the side of a hill or on the side of a ditch where road construction has already gone through, then that could be the PIT method that you would use to describe your soils. The auger method is the one that I recommend. And this is what an auger looks like. This is a Dutch auger, and it's good for most soils. If your soil is really sandy and doesn't have a lot of clay, this won't hold it, and you would have to use a different, this unscrews, and you would have to use a different bit. But this is an auger, it's 1 meter long. I can't get it all in the screen, but it's 1 meter long, and you dig down into a hole that you create that is about that big around. It's not invasive into your, it's much easier, what I'm trying to say, much easier in your area. And so there is one more method called near surface. And this is where you dig 10 centimeters of soil in a square. And so this is just the top, near surface. So you have 3 ways to get soil samples: the pit, that big area that I was talking about, or auger, or near surface. And I would think that you all would do auger or near surface, and that would be easier for you to do. When you are defining your site, this is what is, I've outlined where the soil information goes. You choose where you want it to be. Marlena, is there something that you need? On the site definition sheet, you would give your school name, your site name. Now this might be soil site number 1 if you plan to do several. But if you're only going to do one at your atmosphere site, you might put the site name here of soil at atmosphere, or Mrs. Gomez's soil, or whatever you want to name your site. And then the students that are completing it might be the whole class. So you could just say entire class. The date, month, year, is it a new site or are you updating the site? And metadata is more data than is required. So I know oftentimes at schools, things move around. And if you have an atmosphere station and you want to do a soil, you want to collect soil data from it, and then the school administration says you have to move it, then that would be where you would put meta update. If you've had to move your original site somewhere else, then you would put it into meta update. The coordinates, you know, we have to know where things are in order to understand the data and in order for the data to be usable. So latitude, longitude, elevation. And are you getting the data? Are you getting this information right here, the coordinates? Are you getting it from GPS, or are you getting it from other, which might be a topo map, or your phone? There is GPS on our phones, and so that would go under other. So you select the site type. Are you at your atmosphere site? Are you near your water site, if you have a water site? And so what is the site type that you're doing? Maybe it's just out in a field and you're doing just soil pedosphere characterizations, which is what we're going to be doing today. Cover type, is there grass, dwarf shrubs, bare rock, concrete? The cover type, obviously you're not going to auger or dig in concrete, but if the area around you where you are getting the soil sample has a lot of concrete, maybe you're just off the school ground where there is a lot of concrete and sidewalks and things like that, then you would choose that. And you might be in a closed forest or woodland. What's the ground cover? Is it leaf litter, moss, peat? Then we go on to the next part. Is there a slope? Does it slope, and in which direction does it slope? And is the method that you chose to get this sample, is it a pit, that big thing I was talking about? Is it the auger method that you have used near the surface? Maybe you have a building that's going up and they excavated the soils. So you might want to go and look at that and get some soil samples from it. Is it a road cut? Is it erosional? Meaning that maybe a river has cut down through it and you see soil on the side. The land use, is it urban, agricultural, recreation, wilderness, or other? And then the landscape position, is it a summit, which is here at the top, the slope, which is on this area right here? Is there a depression, like maybe a little stream that's running along here where you're collecting it, that's C? Or is it like a terrace area that's large and flat? Or is it a stream bank? So A, B, C, D, E. That's what you choose. And then we're going to cover this, the information you'll be collecting on the soil characterization in just a little bit. And then the parent material. Is it just there and you know that bedrock is what is the parent material? Organic, maybe you're at a school and you know that it has been disturbed because they've brought in a bunch of fill. And so is it construction material? Marine deposit, lake deposit, stream deposit, all of these have to do with material being deposited from some type of water. Has it been deposited by wind, like loess? Glacial deposits, volcanic deposits. If you live in an area where a lot of ash and materials have been deposited there, or just loose material on a slope. So, and if you don't know, it's okay to check. I don't know. And then what is the major feature from which you're taking the soil? So it may be 1 meter from the atmosphere station. Soil moisture, is it natural, plowed, graded, backfilled? The canopy cover, it may be open, because if it's in a schoolyard, it may be totally open. And then there may be something that you want to say about it. New school, built in 2020. And so that might be something, soil material, maybe fill. You could say that. And then you're taking photos and just making overall comments. So you would be going due north, due south, due east, due west. And then that is your site. Now you've defined your site, and any information that you put in will be there. And the globe knows where it is, scientists know where it is, and it will have a place on our globe map. So soil characterization is describing the soil that you have either gotten from looking at the side of a pit, on the wall of the pit you've dug, or the soil core that you've gotten by auger, or the material that you have gotten at the surface by using a trowel. So that's what we're going to be describing here. And this is what I'd like for you to learn today, is soils are very important. They can be studied, and you'll be just like a detective when you're looking at it. Soil color tells a story. If it's very, very dark, soil scientists know that there is a lot of organic matter in it. If it's very pale, that means that acidic waters have run through it and stripped all the minerals from the soil that the acidic waters are running through. There are many different soils around the world, and yet some of us share the same type of soils depending upon our latitude, our climate, our longitude sometimes, and the topography. Soils are made up of sand, silt, and clay-sized particles, also air and water. Soils vary by what they're made of, where they're located, how long they've been in place, what their climate is, and what organisms have been messing with them. So by what they're made of, that term is, what is the parent material? What was there to be broken down? Where are they located? That's the topography. Are they on the top of something or are they at the bottom of the hill? How long have they been in place? This is time. And when we're talking about soils, it takes 100 years to make an inch of soil, 2.5 millimeters. What's the climate? Is it humid? Is it dry? Is it arid? And so that's going to make a big difference on forming soils. And then what organisms have been moving around in them? So we have microbes, we have earthworms, we have moles and other things that burrow in the ground. One of the things that people forget when we talk about organisms is human impact. And that's a big thing. We dig in soils and move them away. We put concrete on top of them, buildings on top of them, asphalt on top of them. We put pesticides and chemicals in them. And so humans have a lot of impact on soils. And then soil texture by feel is fun. So when we're talking about soil as a lab, and when we're doing studies of it, you should not call it dirt. Dirt is what you track in from your door, and it's not supposed to be there. So soil is dynamic, composed of minerals and organic solids, gases, liquids, living organisms, which can serve as a medium for plant growth. And it's very, very important. So one does not simply call soil dirt. When you're looking at global soil regions, the only thing I want you to see in this particular image is look at the colors that are very similar. We have it here, we have some here, the orange is the yellowish orange is what I'm looking at here, here, and then look in Africa and in South America, very similar soils. And these are the soil orders. And the only reason I bring that up is just to let you know that there are 12 soil orders. When soil scientists are talking about soils, this is how they organize them. And so you see they're all different colors. They've got different materials. They are structured differently. You can see with the histosols there. And then when we're talking about them, arid soils are very dry, arid climate. Ultisols, very weathered, ultimately weathered. Mollisols are very deep, very fertile. This would be where you have lots of vegetation that can grow. Alpha sols are moderately weathered. Inceptisols are slightly developed. So you've got inceptisols, alpha sols, and then ultisols. Entosols are just newly formed. They're just right there. Some of you may live in areas that are frozen. You would have gellisols. Histosols are very organic and very wet. This might be in rainforest and things like that, where you've got lots of rain, but you've also got lots of material coming from trees. So organics like pine needles or leaves from trees. Spotosols, sandy and very acidic. Pine trees grow very well in this. Andisols would be volcanic ash. Oxasols are very weathered, and vertisols are shrink and swell. And these, we have an interstate in Arkansas that is built on vertisols. And so when water gets into that clay, it swells. And then when things dry up, it shrinks. And so that shrink, swell and shrink, shrink and swell, shrink and swell, it just makes the road break apart very easily. And this is all soils in the world, as I've said, fit into these. This is the way you would see it. When you have an order, it's the same as the biological class phylum. Suborder would be the biological class of class. And then if you get down here, the series in soils is what the genus is. And then when they're talking about phases of soils, that's the species. So order, suborder, great group, subgroup. And you're not supposed to know this. I just wanted you to know that there is an organization to soils, just like they have in biology with the classification there. So in semi-arid grasslands, savannas, steppes, shrublands, you'll get soils that look like this. The orangey is iron oxide, and so it's rusty color. In a savanna, you'll get the browns. There's still some iron oxide in here, but not nearly as much as here. In a woodland, notice how you've got the deep browns, very, very nice. And then in a dry forest, you'll get something that looks like this. So soils, depending on where they are and what the climate is, can vary greatly. I'm from Arkansas. This is my state. And one of the things I wanted to show you was the physiography, the physiographic regions of Arkansas shape the soils in our lands. We have the highlands here. We have the highlands here, lowlands here, lowlands here. And we're in this part of Arkansas, we're a dissected plateau. And then we go into the Arkansas River Valley, which you see here. And then we get into the Washitas, which are here. Oops, sorry. The Washitas, which are here, they are formed much differently than this dissected plateau. And the soils here show that. These look very different, even though we call this area the Ozark Mountains, and we call this area the Washitas. The soils that are there are quite different. This is the Mississippi River. You may have heard of that. And this is the Mississippi floodplain in here. This area right here is a glacial deposit called loess. And so you can see how the soils are quite different. In your area, it's quite different as well. And the physiography, the topographic nature of your countries will determine the soils. So in an immature soil, you might have moss and lichen. Young soils, notice there's a little more breakup here. This is bedrock down here. And then you've got rock that's breaking up because of the time and the climate is affecting what grows here, and then what sends its roots down. I gotta quit doing that. There are horizons here, and notice there are little critters and soil or organisms now that can work here. I do want to go to the next picture. When you talk about an O horizon, it is, and this is something important, an O horizon is only organic. There's no sand, there's no silt, and there's no clay. It is totally organic, but it is not what you see here. It's not just grassy areas. If you've ever been in a very old forest and you've walked across the ground under those trees, there'll be a dense peat area that is really squishy. It's like walking on a really, really thick carpet. So the O horizon is nothing but organic. The A horizon is what we mostly see. The A horizon is what farmers call topsoil. There is always a change in color between the A horizon and the B horizon. The B horizon is what farmers call subsoil. And then the C horizon is where you have broken up bedrock, and below that would be rock. So starting from the bottom, you've got rock that weathers into pieces. And then you've got a horizon that is going to be a little more weathered. As the A horizon, as water infiltrates through the A horizon, you'll get a lot of minerals being deposited in the B horizon, and that's why you see the color change. So between the A horizon and the B horizon, you'll see a color change. You may never see an O horizon. We were in Alaska and walked across a peat bog that was there, and it was really squishy when we walked. That was an O horizon, but no sand, silt, or clay here. So here you have the topsoil. Notice it's kind of, this would be probably a cut in a ditch. And so here you've got the topsoil. This will have, this is an A horizon, and notice the color change right here. This is the B horizon, subsoil, and then the parent material is down here. Okay. So this area right here, even though there's grass on it, that's not an O horizon. That would show an A horizon. If you have a really whitish colored horizon, that's an E horizon, because this area right here is so acidic that it's stripping all the minerals out of this area right here and depositing them in the B horizon. But most of the time we don't see E horizons. And then the C horizon is down here where we've got broken up rock. This is a Dutch auger. I was showing you that. That is what a lot of you might be using, or you might be doing the surface. And this is what I wanted to show you. This is a core sample that is 3 meters, a little more than 3 meters long. You have to use special equipment to get that. This is the top. See where it has 0.0? This is the top. Right here, do you see a color change between this really black looking and then it starts getting more rusty? This is the A horizon. And then right here is a change. This is the B horizon. This is as deep as that one particular, or the box they're holding it in. This area right here should fit right here. So this is the first part of the core sample. This would be at ground level, and then they're digging down deeper, deeper, deeper. Then we get here, and then notice there's a little bit of black in here. That's not really in there. You can get contamination sometimes when you're working with soils. This black right here has fallen over into that, so you don't count that. And I'm surprised they didn't move that out. But notice they look to be little nodules in here. Sometimes you'll see manganese if it's black. You can see rusty little nodules in here. Those are iron oxide nodules. So you can see it's getting rustier and rustier colored. Here, this fits here. And then if you were digging with a Dutch auger, you would get to about right here. Then they have something deeper or that can dig deeper. And so it's going down. Notice there's a light area in here. That's something different than what we've seen. So this area then fits here. And then as we go down, does this look like kind of clay-y to you? Looks like a lot of clay in here. And then something went on here. And then we go on down, another episode of something different here. And then this part fits here. Notice there's a difference here. Oh, sorry. Notice there's a difference there. And then they finish the core. This has not gotten into bedrock. So when you're listing this, you would have to say 3.2 plus meters because we haven't reached the bottom of the soil yet. The soil extends more than 9 meters. So this is the sheet that you fill out. And don't worry with your students about doing A, B, and C. What you're doing is numbering the horizon. So here's a core sample that we have taken. And here is where I notice a change, a little bit of a change. I notice a little bit of change here. There's a little bit of difference here. Now, there are clumpers and there are splitters, and I tend to be a splitter. I look at what I'm seeing in the core sample and then look at it really closely and decide. Some people might want to lump all of this together because it's that dark brown. And some people, I have split it here, here, and here. But some people might want to just have this whole area be, this would be one area, and this would be 2, and this would be 3. So it depends upon what you want to do and how detailed you want to get with your students. This area right here would be the topsoil, and all of this under here would be subsoil. And that's fine if you want to do it. So the numbers that I associate with this area right here goes here. The date, month, and year goes here. And then the top depth. So if we're starting here with this core sample, we have augured a core sample. This is the top. Oftentimes I put grass on the top just to help me remember which ends up. And I want to show you, I don't know if you can get, these are fluorescent light tubes. They cover, hospitals use them a lot. If you have hardware stores, they might have these if they sell fluorescent lights, but I've capped it with a PVC cap. And this is a soil core that we got. And it's a little hard for you to see on camera right here. This is darker brown. You get to about in here and it starts getting a little rustier colored. And so we've made 4 or 5 of these to show students. Does that make sense? After we've taken the soil core, we put the soil in. And then this is a way that we can show students changes in color in soil, different soils from different places. And this is one way that we have done what you see here on the sheet with the soil core. So this is about the length you would be taking a soil core. It's about 1 meter. And that's what augers do. So when we're looking at the top depth, here's the soil core. This would be 0. The top right here would be 0. And then where I have said there is a, in fact, unmute yourselves just a minute and you talk with me about this. So if we are here, can you unmute? So Andrea, I see that you are, I'm putting you on the spot. So here is 0, and that's what you would put here, 0. And then the bottom depth is about right here for this particular one. What would you put in bottom, in the bottom? Right here would be 10.
10 centimeters.
Okay. Then the only thing that I'm going to say more about this is then when we go to the second part of the soil core, we are going to take 10 and put it here, because we start with the bottom for the top of the next layer. So it would be 10 centimeters here, and it goes to, okay, so
About 16.
oh wait, I'm sorry. It's not 10 centimeters is from here to here. So that would be about 5, right? If we're cutting that 10 centimeters in half. Right here. I'm sorry, the arrows are where the numbers are.
Yes.
So this would be 5, about 5, maybe. Does that make sense?
Mm-hmm.
It's about half of the 10. And then in the second part, we would put 5 and go to, what's that? 20 centimeters is right here. So how much would that be?
About 12.
Yeah, I think so. The point being 0, 5, 5, 12. And then 12, and then whatever else the rest of these are.
Okay.
Does that make sense? You use the bottom depth to start the top depth of the next part of the core sample that you are looking at. So as I said, I split things up, but you could do this whole thing right here. You could do that as one right here, and then do all of the rest of this as 2 to make it easier for your students. So when you're talking about moisture, is your soil sample dry? And when I'm talking about dry, I mean this. This is just like powder. You see that? That would be totally dry. Is it moist, meaning you can tell there's a little water in it, or is it totally wet? Did you have a rain yesterday and the soil is, so you feel the soil, you feel it to see if it's dry, moist, wet, or if you just don't know. I can't tell. Structure is, we're going to talk about this in a minute. Main color is from the soil book. If you want sometimes in a sample, there will be 2 colors. It may be blended a little bit. And if oftentimes there's not a second color, but if there is, you would put that here. We're going to talk about consistency and a little more texture. Roots, are there any roots? And are there any rocks? Carbonates, we'll talk a little bit more about that in a minute. So structure, when we're talking about structure, structure is simply how the soil holds together. Is it granular or crummy? This would be like washing powder. Granular, you can tell that there's a little bit of clumping together. I'm trying to think what else you might have. Do you know what I'm talking about when I say washing powder. It's not sandy, it's just little tiny clumps. And so that would be granular. Plate-like, you see this oftentimes in areas that have had a lot of foot traffic, where it's just like sheets in a book. When you go down through the core, you will see some of it that's just really platey. Looks just like that, looks just like sheets in a book. If you've had it compacted from years of walking, you'll see that. Metamorphic rock that has turned to soil will look like this too. We were in an area in the western part of the United States. I took my rock hammer and I hit what I thought was metamorphic rock, and my hammer went straight into the side of the mountain because the metamorphic rock had turned into soil, but it still looked like metamorphic rock. It was really interesting. Granular is here, blocky is this, and it's just like what it sounds. You have a block that's about the size of a nickel to a quarter, and if you can hold on to it about like this, that would be considered blocky. Hold it like that. And then sometimes you will see prisms, columnar or prismatic. The only difference between these two is how the clay holds it together, and you've got kind of a bump on this columnar. It's a rounded top, whereas the prismatic isn't. You see these in place. You're not going to see those when you are augering. You just won't see them. So you'll see blocky, or you'll see granular, or you will see just a clump. If it has a lot of clay in it, it will just be a huge piece of, looks like ice cream that hasn't melted. So structure is how it holds together. Consistence is how it falls apart. Sand is loose because you pick it up and it just falls through your fingers. It doesn't stay together, so it is loose. Friable means you can take a piece of soil and pinch it and it will break apart. So you take it and you can just do like this and the soil falls apart. It was a ped, that's what you call a little piece of soil. It was a ped, and then you do like this and it just falls apart. And then if you've got that ped and it won't break, you know it's soil, you know it's not a rock, and you start to try to press it and finally it pops, that's firm. And then extremely firm, you cannot break it, you can't do anything with it, and you have to break it with a hammer. That's extremely firm. Clay will hold things together. So if you have sand, silt, and some clay that is not too dry, it will break apart. It will be friable. If you've got clay that's really dry, your sample is dry, it will be firm and you'll have to really pinch to get it to break apart. If you have to break it with a mortar and pestle or with a hammer, the clay is just dry. Sometimes you might see mud cracks in that type of area because it's so dry and there's so much clay, it's just like a brick. So when we talk about soil, we're talking about sand, silt, and clay. 2 millimeters or less. Gravel that's bigger than 2 millimeters is not considered soil. So we're not talking about gravel pieces. We're talking about the soil would be sand, silt, and clay. Sand feels gritty, like an emery board. Silt is very smooth like a mud mask that you might use on your face. Clay is really sticky, and some soils can have all three, obviously. I made a song up a song that we sing to the tune of Three Blind Mice. Sand, silt, and clay, sand, silt, and clay, make up earth soils, make up earth soils. Sand is gritty and feels real rough. Silt feels smooth and is smaller than sand. Clay is the smallest and sticks to your skin. All of them go together to make earth soils. Hooray for sand, silt, and clay. And sorry, I'm not a good singer today. My voice is gravelly, but that I will show you where, if you're interested, I'll show you where to get that song to work with kids. But sand feels gritty, silt feels smooth, and clay is sticky. Another thing about sand and silt, they are the same mineral. Silt is just a smaller version of whatever mineral the sand was. Clay is a completely different entity. It has weathered to the point that it is different. But when you talk about clay, you're talking about clay-sized particles, which we can't see. We can feel them. We know they're sticky, and it's really, if you take a mudstone or a clay stone, rub it against your teeth like this, it's smooth. If you rub silt, a silt stone, against your teeth like this, you're going to feel like you've just rubbed an emery board across your teeth. I mean, it brings the hair up on the back of your neck. While silt feels smooth to your fingers, your teeth are more sensitive, and you can feel in a silt stone, in a rock made up of silt, you can feel the little grains in your teeth. Sand is really gritty, and you can feel it. A sandstone, you can see the grains and you can feel the grains. So sand, silt, and clay. So when we're talking about what makes up sand, we've got basically 50 and 50 between air and water and minerals, sand, silt, and clay in the minerals, and organic matter. There's going to be something that's organic in there most of the time. So, you know, give or take about 50-50 in soil. There have to be air spaces for air to get down in, for roots to be able to grow down, and water to help those roots grow. So this is a textural triangle. And unless you're a soil scientist, this is not going to mean anything to you, except you see the word clay, you see the word silt, and you see the word sand. Soil scientists, and when you are using the hygrometer, if you were going to do that, that protocol, this is what you would be working with. We look at sand, how much silt, and how much clay are in all samples. And here you can kind of see a difference. But if I said to you, silt loam, silty clay loam, silty clay, clay, clay loam, sandy clay loam, that doesn't mean a whole lot. What I want you to see from this is there is a lot of clay. You see the word clay, clay, clay. There is a lot of clay in most of our soils. Clay is sticky, silt down here is smooth, and sand is gritty. When we talk about loam, farmers like the word loam. It's a mixture of sand, silt, and clay, and you can see this loam and clay loam are right here in the middle. So I'm going to show you how this works. We've got a sample that we know is 75% sand. We've done the lab work. It's 10% silt and it's 15% clay. So what does that mean? This is how soil scientists do this. There's our sand, 75%. Everybody see that? Here's the 10% silt. Here's the 15% clay. Now we've got those 3 dots on our textural triangle. We go up with sand, down with silt, across with clay, and where this meets, where all 3 of those meet, that's what we call the soil. So this is sandy loam. Does that make sense? That's not a test. You're not going to have to do this. I'm just showing you why I like the texture by feel chart you're going to see in a minute. All right, let's try it one more time. We've got 10% sand, 83% silt now. So this is going to be real smooth, and 7% clay. So let's see what, here's our 10% sand, 83% silt, 10%, or excuse me, 7% clay. There's our silt, there's our sand mark, there's our silt mark, and there's our clay. So here's where all 3 of those meet, and it's silt. So this is complicated. High school students could do this if the teacher and the instructor understand how to do this, but this is where we get into the soil texture by feel. And this is what a lot of soil scientists do in the field when they are looking at soil. They do it by feel. And that's where the soil samples are going to come in. So I've structured this by steps. They're basically 5 steps that we're going to do. And if you have your soil sample, I want you to get it and the water and get ready to do this with me. So soil texture by feel, you're going to put a soil sample in your hand. So get a soil sample and put it in your hand. So I don't know if I've got just the soil in my hand. About 1 to 2 spoonfuls. If you're using a spoon, just about 1 to 2 spoonfuls. And then I have a misting bottle, and I'm going to mist it. And if you don't have the mister, then you can just make it wet. And then you're going to work it. So to start, place 25 to 50 grams of soil in the palm. You're going to knead the soil, mush it around until it makes a ball. I have done this with seniors in high school. I have done this with 2nd graders. So you want to make a ball, and does the soil remain in a ball when squeezed? If you say yes, you're going to follow that 1 column. If you say no, the question is the soil too dry? If it is, you're going to add, if it is too dry, you're going to add water. If it's not too dry, is it too wet? This is what I have right here. My hands are filthy, but so does it remain in a ball when squeezed? Mine does. Now, sand sometimes will hold together, but you have to press it pretty firmly. And mine does stay together. Is the soil too, if it doesn't stay together when squeezed, is the soil too dry? No. Is it too wet? No. Then you call it sand. Remember that textural triangle we were looking at? You call it sand. Okay. All right. Now, we're hold on just a minute. Let me go back. Okay, so step 2 is forming a ball, and we've done that. Step 3, learn to ribbon. You're going to place this in your hand. You're going to squeeze it. And you're going to try to make a ribbon that's going to extend over your hand. Mine's a little bit too wet. I need a little bit more. Does the soil form a ribbon? And mine will. If I can get it the right consistency. But you're pushing it over. You're pushing it over your finger. And the idea is to see if you can form a ribbon over your finger. And this takes practice. I've had students that have been so frustrated with this, but it takes a little practice to make a ribbon. And sometimes it won't make a ribbon. It may make a very short ribbon. So you're taking it and you're pushing and you're pushing and you're pushing. And the idea is can you see how it's sticking together? Does it form a ribbon? Yes. If it doesn't, does it feel gritty? If it won't make a ribbon, does it feel gritty? If you say yes, then it's loamy sand. Does it feel gritty? No, then it's silt. Clay is what makes this stick together. And so if there's very little clay in it, it's not going to form a ribbon. So you'll either have loamy sand or silt. All right, if it forms a ribbon, we said yes. Does it make a ribbon less than an inch? If it does, we're going to follow that first column. Does the soil make a ribbon that's 2.5 to 5 centimeters before breaking? If we say yes, we're going to follow the middle one. Does the soil make a ribbon 5 centimeters or longer? My soil's not. Mine is going to be yes. It does make a long ribbon, but my soil's not working with me today. So we're going to follow those columns. You can see in this person in the hand there on the slide, you push. You are pushing, pushing, pushing to make the ribbon go across your finger. And it does take practice to do this. All right, now put all the soil, put most of the soil away. Look at my hand. Put most of the soil away, the ball away. And now you're going to wet the palm of your hand and you're going to rub your hand. Excessively wet a small pinch of soil in the palm and rub it like this. Does it feel gritty? Now this is the short ribbon column. Does it feel gritty? Yes. Then you've got sandy loam. Does it feel smooth? Is it mostly smooth? Yes. Then it's silt loam. And if it doesn't feel gritty or smooth, you can't really tell, then you just call it loam. That is the column with the 2.5 centimeter ribbon. If it is 2.5 to 5 centimeters long, if you got it that long when you ribboned it, then is gritty the most that you feel there? If yes, you say sandy clay loam. If no, Does it feel smooth? Yes. Then you call it silty clay loam. And if you can't really tell it's got grit and it's smooth too, then you call it clay loam. Then if you've got a ribbon that is 5 centimeters or more, does it feel gritty when you rub it? If yes, then it's sandy clay. Does it feel smooth mainly? Then it's silty clay. And if it is neither gritty nor just smooth, you have clay. Mine is silty clay. Look at how it's sticking on my hands. See how all that's clay. And if it feels really smooth, that says it has a lot of clay and silt. The silt feels really smooth. And then if it's gritty, if you're feeling grit on your hand, then it is sand. So ribboning is very important to get the length. And then following these columns is important. Questions? I'm going to stop here a minute for questions.
My color is darker than yours. It's
Yes.
the same. It could be, clay.
Yes, color won't
Sandy
matter.
clay.
Color won't matter with this.
Okay.
This has nothing to do with color. It just has to do with the way it feels. So yes, yours could be quite different from mine. I'm going to wash, well, I can't wash my hands. Got something in my sink. Your color could be quite different. Yes.
Okay.
Other questions?
En la
Ok.
identificación, entonces sería más importante la textura.
Yes. Yes. And if with the time limit that we have today, if somebody wanted to work with me over Zoom, I would be more than happy to work with someone to do this texture. Okay, we'll go on. All right, so what do you think? Tell me what your soil texture was. Was anyone able to?
En el caso, la mía, sí. Y en el caso, el mío era con una textura como si fuera arena, arenoso.
Okay.
Sandy clay.
Anyone else?
18.
A mí me dio arcilla limosa, me parece.
Okay. And I want to go back just a minute to this. This is what we were working with. So is it sand? It won't stick together at all. Right here, won't stick together. If it does stay in a ball, then does it form a ribbon? And if it does, the ribbon, is it weak? Is it less than 1 inch long? We use inch, I'm sorry, in the US. 2.5 centimeters, then it would be down this way. Medium ribbon, 2.5 to 5 centimeters would follow this. And if it makes a long ribbon, then it follows this column. And that's what I did when I broke it up so that, and you all are welcome to use my PowerPoint if you would like to. You're more than welcome to use this. And then here are the directions step by step. Okay, so now this starts making a little more sense. Mine was clay. I had so much clay. Some of you had silty clay. Some of you had sand, and that's where we find it on the textural triangle. All right, we're going to move on just a minute. Soil color is very important to soil scientists, and colors. This is a color book that is used all over the world by soil scientists. Globe modified it just a little bit so that it wasn't quite as expensive, because the Munsell color book is about $150, and Globe modified it so that it was a little less expensive. And this is what the Globe color book looks like. And this is what you see in this picture. They've opened it up, and notice the colors vary. My hands are filthy. The colors vary depending upon where you are and what the soil is. When you are doing soil color, you need to be in sunlight, not indoors with fluorescent light. You need to use the soil color book, and your sample needs to be moist. And I want to show you why. It's hard to tell how wet something is. Look at the color of this, and then I'm going to moisten it just a little bit. Doesn't have to float. All right, can you see the difference in the color where I moistened it? All right, so when you are getting the color, you need to mist your sample a little bit. So if you have high organic material, in fact, if you've got your soil sample there, wet it just a little bit and see it change color. It will change color. Mist it just a little bit and see. Andrea, if you have really dark soil, it'll go a little darker, but it won't go too much darker. Yep. And that's a good example of what to do. White, clear, or black underneath your soil sample is best for seeing color. If you've got a plate or something with a lot of colors on it, it may affect the way you're seeing the sample. So you would take that outside. You would use the soil color book because it's damp, using the sunlight, and then the soil color book to determine your soils. If it's black, it has a lot of organic material in it. If you've got white in it, it may have calcium deposits. Red-orange means iron, and gray-blue means that, and this is where chemistry comes in, you've got oxidation going on. Oxidation when air hits it, and reduction when it's in ponded water. You may have a wetland, and you may have some really gray-blue soils, and I'll show you what I'm talking about with this book. You may have some soil colors that look like that. That tells us that it's in a ponded situation because these are reduced colors. And then you get into something that is like this, and you've got oxidation going on because you see the rust coming out in it. Any questions? Now, this looks really confusing, but I want you to look at this just a minute. Did you have a question?
Sí, yo quería consultar sobre el tema de que para las cartas de colores, ¿cómo podemos hacer para conseguirlas?
Where are you? In what country?
Argentina.
Argentina. If your country coordinator can help with that, we'll have to talk about that, because sometimes you can make your own, and that might be something that you do. There is a code right here that is used for soil science color. It's hue, value, and chroma. That's the three things. And all that means is the color you see is the hue. So is it brown? Is it red? Is it yellow? And then this value right here says, is it black going to white? See how much lighter that gets to here? So the value is black to white. And then the chroma, which is this last one right here, I've always said how much gray is in it. It's the strength or weakness of a color. This down in this area is really gray, and you can see it gets less gray, less gray, less gray, less gray. So hue, value, and chroma. This is a code that soil scientists use when they're talking about a color of a soil. Because if I say red, am I talking about something this red? Or am I talking about something like this that you might call red? Or this over here, that's a red. So they use this code because everybody then can go in and look and see the code and look at the exact color. And that's what's underneath each one of these. So you might say, I have a 5YR, that means yellow red, a 5YR 7/2. That's the way you say it. And this looks really busy, but just take these and divide here and here. So hue is what we see. Is it red, yellow, greenish, blue? What is it? What color is it? And then how dark is it? Is it really light colored or is it really dark colored? And then the strength, I just say how much gray is in it. And the less color, I mean, the less number you have here, the darker the color. See over here in 14, there's nothing. You don't see any grays in here. All right, this is the United States, and this is soil color by depth. I just thought this was something kind of fun to put in. Here's the Mississippi River right here, and here's Arkansas. See where we split? Our state splits right here. That's the Arkansas River right there, and here's Mississippi. And this is the Mississippi floodplain right here. And I live up in this area right here. I live right up here. And so look at the change in colors by depth. I just think that's amazing. And it's also pretty. So this is right at the surface, then a little deeper, a little deeper, a lot deeper. So the colors change by depth. All right. And this is just our states with all the different colors our states are. The colors of soils in our states. This is Arkansas right here. All right. So when we're talking about soils, soils are extremely important because of what we grow. And so pH, is the soil acidic or is it basic? And we have a plant called the hydrangea, and whether it's pink or blue determines the soil determines those colors in it. So I like this one because it kind of relates to things that we may have in our houses. We talk and we think in terms of acids being bad. They're not. Look at stomach acid. It's about a 1, 1.5 to 2. Lemon juice is a 2. This area right in here of 6 and 7s, that's about where you want to be with soils as far as basic, but you may have to add something to it or something may not grow because it's either too basic or it's too, too basic or too acidic. Drain cleaner is just as bad if you think of something as a car battery acid. So either end of the scale is not good for plants. This area right in here is where we look at plant growth. So there's two or three different things that you can use for pH. Some of you may have paper that comes like this, and it's just little strips that you tear off and you put into the soil water, and some of you may have pens. Most all of you will probably, if you're doing pH, will have this paper. And it's just little bitty strips that you compare to the colors that you see on the sides of the container. So pH is important because certain things grow. pH of water is important because certain pHs are good for certain fish and others are not. So pH is important. And there is a guide to it. This is soil pH protocol. Here you see plant growth in this area right here. Basic, acidic, and what will grow where. Cranberries grow in a very acidic soil. All right, so the protocol is real easy to follow. You mass it, you mass the sample, and I've got, these are just little bitty scales, but you mass the sample, and then you stir in distilled water. Here are the directions right here in the materials. Stir in the water, and then you let it sit. And this is a little, I started to do this blue. This is a little hard to understand. Here's the soil once it settles. Here's the soil down here. And here's the water. It's called supernator. The supernatant right here, you stick the pen or the paper in the water, not in the soil. So you've stirred it up and you've let it sit for about 5 minutes or so. And then you read the pH. You're going to do 3 samples of each that you test, and you let them know whether it's paper or meter, and then the pH of the soil and water mixture right here. And here's where you put the segment that you're testing. Are you testing what's the top and what's the bottom and the horizon number? So you may have number 1 horizon and number 2 would be a separate set of pH samples. So you do 3 samples for each. And here's the lab. And remember, you were testing the water, not the soil down here. And so I have a bottle here that I can show you. You see the soil here? You would be testing in this water. All right. The NPK that we do for soils, the kits are not real expensive. You can test it with whatever you've got, but this is an NPK kit, nitrates, phosphates, and potassium. Those are all necessary for plant growth. And so nitrogen helps the leaves, phosphorus helps the roots, and potassium is just good for overall health. So you want strong leaves, strong roots, and you want healthy growth. Hey, Marta. And so this is what the kit looks like. The process is very simple. It's easy to do. And as I said, these kits are not real expensive. I wanted to get here. So what you're doing is you're creating a sample, and then you're shaking it up, and then you're pulling from that sample into smaller test tubes, and you're putting tablets in it, and you're shaking and shaking and shaking, and then you're comparing it to a color chart for nitrogens, for phosphates, and for potassium. So it's actually really, it's kind of fun to do. And it's not difficult to do it all. So pH and NPK are not hard to do. You just follow the directions and it's really simple. And so here's the soil fertility: nitrates, phosphorus, potassium. You do it sorry, I have dogs. You do it three times. And then you're also going to record, are there rocks? Are there roots? And maybe you've got a critter. Now, if you've got a critter, and by critter, I mean, you might have an earthworm, you might have a little roly-poly, there may be ants in your sample. So you would take those and put them back out where they came from. Don't throw them in the trash. You uprooted them from their homes. So whatever the critter is, you would record that also on your sheet. And then the very last column asks about carbonates. And if your soil has calcium carbonate in it from limestone, it will fizz. Hydrochloric acid, it just takes 1 or 2 drops and it will fizz. It'll look just like Alka-Seltzer if there's calcium carbonate in it. Sometimes it's suggested to use vinegar, but vinegar doesn't work as well. If you can get hydrochloric acid, it works well. So I've got, this is an activity. Why do we study soils? I'm not sure how much time do I have left. I'm looking at the clock. We started a little late, but I'm looking at the clock wondering.
Yes, don't worry, Lynn. It's all your time, because then we are going to have the K4 activity. So if you are going to use some more time with this activity, we are going to have just a few minutes less for the other activity, or maybe we can have a shorter break.
Okay. Okay. This is something that I want you to have as well. It's the second part, but I want to go back. I'm going to go back to sorry, I should have had this already in my slide. I wanted to go this. This is what we talked about. Okay, well, this is what we talked about. So I went through every part of this soil characterization chart. You would, for each segment that you're doing, 1 segment, 2 segments, or dividing it up, for each one of those segments, you would fill it out all the way across. And you could say unknown. If you don't have hydrochloric acid, then you could say unknown. Do you have any rocks? Do you have any roots? You know, whatever. And then here is your texture field estimate. That's where you would use the texture by feel. And then consistence. How does it hold together? Does it just fall apart like sand? So it's loose. Does it, when you press it, does it fall apart pretty easily? Then that would be friable. If you have to really press it, it's firm, extremely firm. You have to use a hammer to break it apart. Here's the main color from the soil color book. And then the structure is how does it hold together? So in the PowerPoint that I have, we have gone through all of these. Okay. All right. So let me run through this. Okay. There is an activity in the Globe Learning Activities called Why Do We Study Soils? And look at all these beautiful colors of soils. I just love it. I mean, to me, and I've had 2nd graders with bows in their hair and little dresses on. We cover them up working with soils. And one of the little 2nd grade girls said, "This is so much fun." I'm going to do this at home. And I thought, your mother's going to hate me. But anyway, studying soils, the colors are just magnificent. Okay, so the globe learning activity, why do we study soils? The activity one is, why are soils important? And when we think about it, people use soils for making material. They stain materials. They do sand paintings. They make clay sculptures. Soils are used in cosmetics. They're used in medicines. And they're used for building things. And sometimes it's just plain fun to be in a mud puddle. So why are soils important? There are a lot of things we do with soils besides what we do as far as building homes on it, building homes in it, and our plants use it for their bases. So soil forming factors, we've already talked about that. Are all soils the same? This is another part, another activity in this learning activity. And as you see, they're not. And then I'm not going to go into this, but just look at the difference. This is a history of this area told in the soils. And so you will have this activity and you can see it. How much soil is there on Earth? I took, and Monique, this is something that we did with you, and you're responsible for this because apples are so expensive in some areas. Sometimes we've used apples and the kids divide them up, but then you have to have knives and you have to have plates and you have to have apples. So I did an activity with a strip of paper, and this is what I'm going to show you. It doesn't matter the size of the strip, but I just took strips of paper. And so here you have a strip, and these are the directions for how much soil is there on Earth. And so there are 4 equal sections. You fold the strip in half, and then you fold it in half again. So when you unfold it, you have 4/4. Does that make sense? Okay. Then 3/4 of the Earth is covered in ocean. So that's 1, 2, 3. So this is all the part. If all of this is Earth, this is the only part we have left that can be land, because the rest of it's water. Then we have to fold it again because we've got areas that are not suitable for farming: deserts, swamps, mountains, and polar regions. So we fold it again. And then this is the land suitable for soil. So all the rest of this right here is land and ocean not able to grow crop. Then we've got some of this soil is too wet, it's too rocky, it's too hot. So we have to fold this again and again. So now this is the section of that whole long Earth. This is the part right here that is suitable for farming in all of this. So if you wanted to do fractions, this is the fractions of it. This bit right here is the area that can grow food. It's the topsoil in which we grow it. This is what it looks like. So the strip has gone from this to just one little bitty part right here on top. And we depend on that part right there for everything that we eat. So we depend on soils. And this, if you wanted to turn it into a pie chart, this is what it looks like. So that's water. You can take this strip and make it a circle. I don't know if you guys have ever done this before, but if you take the strip and it's all divided up, because the kids have marked on the strip, then you take it and you fold it and put it on this circle. Everywhere you've made a line on this strip is what I'm doing now. So this part right here is water. And then you've got land, desert, swamp, mountains, polar regions that you can't grow on. It's too hot, too wet, too rocky, crop land, and topsoil. So this is how, if we turned our piece of paper into a circle, this would then be a graph that the kids would have. And so this is what you see in a lesson activity where the kids just fill it in. I thought it was better for them to make it themselves. And so here's the lesson. And here are the directions for the paper strips. And this is the paper that you use. I've got this lesson for you if you want to have it. So that is, in a nutshell, soil characterization. And I'll stop sharing. Okay, do you have questions? Kind of went kind of fast.
No tengo una pregunta, pero quería hacer una aclaración. Yo soy la coordinadora de Globo Argentina y como escuché que había una participante que estaba preocupada por el librito para clasificar los suelos según el color, como dijo Lynn, es muy caro, es muy difícil de conseguir en Argentina. Quizás se pueda conseguir algo parecido en internet, pero de todos modos, la idea, como hicieron en otros países, es escanear el librito y lo único nos tienen que dar tiempo y se los vamos a mandar a los docentes que están trabajando en Globo Argentina. Así que quédense tranquilos con eso. Y el otro tema es que para hacer toda la parte química, también para nosotros es difícil conseguir el material que se obtiene de la MOT, que es el que usa Globo. Pero generalmente en cualquier laboratorio de las escuelas tienen los elementos como para poder hacer, estudiar desde lo químico el suelo. Eso quería aclararles. Bueno, gracias por el espacio para poder aclarárselos.
Marta and the rest of you also, Y laces with Dixon Butler might be a way to get some of these as well. He has a grant that he does for student research, and I would look there.
Thank you, Lynn.
Lynn, can you put that on the chat, the resource? Why just?
Yes, it's, I don't have the link for it, but it's called,
I'll Google it.
it's Y laces, and I can send that. I can send that to you and Marta or whomever. And then you can send it out to everyone.
Yeah, to Mariana, and maybe she'll send it. And the same thing for the resources, Martha, if you can send, I mean, if Mariana can just resend it, because that way we can all have it. I see people from Colombia asking, and also like my teachers from Paraguay are also asking. Yeah,
yes, I will send a link.
I just added the link, Lynn, to Y
Oh,
laces.
hi, Tony.
Hi.
But I have a link to this PowerPoint and everything where people can get that. It's a Google link, and I will send that to the contacts, and then they can send that out. And it's the same thing with the kindergarten pages. I have a lot of materials in the kindergarten section, and I want you all to have access to those.
Eileen, you can send them to me and I'll resend them to everyone who participated in the meeting.
Perfect.
It's the same email where you sent the rest of the resources.
Okay, perfect. I think we could take a break. And do you want to start in 15 minutes?
Yes, that would be great.
Okay, that way I can wash my hands.
We can all go and wash our hands.
Yeah, all right.
A todos nos vemos a las 5 en punto. Mientras tanto, los dejamos con nuestros queridos student bloggers de Latinoamérica.
Tired of your poster not helping you in your presentations?
Do you find it hard to explain them?
Is it the first time you make a poster and you don't know how to start?
First of all, what is a poster? A poster is a very effective way to communicate your own research idea or project to many different types of audiences. In this video, we're going to teach you how to make an effective poster and how to present it in an appealing way.
First of all, we're going to go step by step. The first step is ask ourselves 2 questions. Where am I going to present it? It is important to take into account who the presentation is aimed at. That will give you the complexity of the explanation, and then you will know how to attract the attention of the public. The second question we have to ask ourselves is, does the assembly of that poster have any requirements? We must always pay attention to the format that the organizers ask us. For example, size and type of font, colors, layout of text and images. And if they don't ask for any standard, we recommend you to look for some design to inspire you and be able to make your own.
Organize. We are not going to design our poster yet. First, we have to combine the information we are going to use and adapt it to our audience. We shall look for the images, photos, drawings, graphics, the text, and an interesting title.
Step 3. Design. It's time to get creative. In this step, we will put together our poster finally. If you have a format to respect, don't forget to do it. It all depends on how you want to put together your poster. But we leave here you some tips and a little inspiration. Have the information well organized by sections, and that those sections are distinguished from one another. Don't write too much. Using keywords is always better than having a lot of text.
Use creative graphics, for example drawings in PNG with transparent background and that they have a similar style between them. You can also use innovative elements like QR codes that serve to complement the info, and if your poster is digital, you can also use videos, animations and audio.
Use a color palette. Take into account the contrast of the background with text and other shapes.
Use readable text fonts. You can combine fonts and style, using font sizes evenly. Leaving a border and distributing the sections in a spaced way gives a striking and neat design to your poster.
Add contact information too. Name of you or your institution, and any means in which they can contact you.
Use a program in which you feel comfortable to design it.
Step 4. Verification. Try that the poster is understood and that it helps you when explaining it. Ask a friend or family member to give you their point of view, to know if it is understandable and visually appealing.
Something that serves us is to study and practice before presenting. And also you can tell your own story and how did you came of what you did. When you are presenting your poster, try to make as real as possible. And also when you are practicing before the presentation. And also having a good poster that harmonizes with the audience and with the place you are presenting is neater and also striking.
We hope you like our video.
And we want to see your presentation in a Globe presentation, of course.
Don't forget to like, comment and subscribe. And if you reach this part of the video, comment poster with Mate's presentation of bosses.
Hello. We are Juan, Mayanela, and Lucio.
And we're going to show you how to do water quality and the environment where we live.
We hope you will enjoy it.
Let's show you who we are and what we do. We live in a small town in the south of Argentina.
We enjoy doing water quality analysis in our river as its landscape is amazing and calming.
We usually do our measurements around the Chimewin River.
Our city is surrounded by mountains where we can see beautiful landscapes. During spring we have a nice landscape too.
During winter, it snows a lot. Let's start.
In this case, we are going to use a small water quality analysis kit. So, we first are going to take the water sample, which consists in submerging the flask in the water and taking it out. In our case, we can compare the turbidity immediately. In this river, it's always 0. We are going to show 2 ways of measuring pH. In this one we can see that it needs a peel. Same we do with the dissolved oxygen, the smaller flask, and we agitate both flasks and then compare it with the table that comes with the kit.
In this other way of measuring pH, we have comparing stripes. We wet one of the stripes and then we compare it with the table on the package. In the comment section below, you can say what was the difference between each value.
We are going to take a look on how to do the alkalinity with another type of kit. We are going to follow the kit's instruction and amount. This one also has a peel and we agitate the flask until it dissolves. In this case, we need to do the titulation, so we add drop of the liquid above until it switches from blue to purple.
Be careful, if it turns red, you must start the titillation again.
After it turns purple, we see which number was left on the syringe, and that's our alkalinity measurement.
Thanks for watching. Don't forget to like, comment and subscribe.
And don't forget to share it with your friends. See you on the next video.
Bye.
Bye.
Don't forget to...
Hello, my name is Autumn Burdick, and I am the Globe Program's social media lead. Today, as part of our celebrations for Earth Day and our 26th year, I would like to introduce to you all some very special students, our Globe student bloggers.
Hello.
Hi, I'm Ranji Joshua Alayan from the Pearl of the Orient Seas, the Philippines.
I'm Hala. I come from a country of origin, where past and modern both join together.
My warmest greetings to the Globe community. I am Susanna Makoba and I'm from the beautiful country of South Africa.
Hi, my name is Christine and I'm coming to you from California, United States.
Hello, my name is Johannes. I'm from Estonia.
Hello everyone, good morning, afternoon or evening wherever in the world you are at right now. My name is Maya Pacher Arnold. I am 16 years old and I am a Globe student for Colegio de Todos Santos.
Hello everyone, I am Lakshmi Vinayar. I am 13 years old, studying in 8th standard at SMV HSS Pune in Kottayam district of Kerala. I am an Indian citizen.
Oh, here you are. Good afternoon everyone. I am Xavier Malloy from South Africa. I live in a small town, not a small town, but a town called Impangeni, and that is in KwaZulu-Natal. And that's approximately over here. Yeah.
Hello, I'm Rinada Mohammed Sheikh. I'm 15 years old and I'm studying at grade 10 in Mizon School, Taqa, Dhafar, Sultanate of Oman.
Hello, my name is Hannah. I am 13 years old and got back to the Gojo College Middle School.
All my life I've loved talking about the environment, conservation, and what we can do to improve our planet for the future.
good morning, afternoon, or evening, wherever in the world you are at right now. My name is Maya Pacher Arnold. I am 16 years old and I am a Globe student for Colegio de Todos Santos. I am living in the province of Buenos Aires in Argentina. I live in the outskirts of the big city of Buenos Aires, 30 minutes away. I live in the district of Vicente Lopez, which is a very green district. In every street you see at least 3 trees, which is amazing, and the oxygen is very clean. The sky is often blue with some clouds on it, and at least once a week it rains. It rains quite frequently because the weather is very humid down here. There are lots of bees, bumblebees and butterflies, but that means there's also a lot of mosquitoes, which we don't like a lot because many of the mosquitoes can carry a virus called dengue, which can be deadly or can leave you really sick for a couple of days. But the amount of mosquitoes is not as huge as it is in the north of the country, so we are kind of lucky. There are many flowers and trees, as I said, and you can see many trees called Araucaria where I live, in the streets where I live, which I really like. The environment, all in all, is really friendly. The people are so kind and so nice. You can say hi to a neighbor you don't even know and they'll say hi back, good morning. Everyone is super duper nice. And you can often see neighbors drinking mate, which is an Argentinian typical infusion, which I love, down the sidewalk. In comparison to other districts, Vicente Lopez is quite safe. I feel safe when I ride my bike or I walk around the neighborhood. In this district we care a lot about recycling. We have certain days where a recycling bin truck will come and pick up all the recyclable trash. We also care a lot about pollution and taking care of the river. Moving on to me, I'll tell you a little bit about myself. I love animals, I am a vegetarian, and I have 10 cats and 3 dogs. I am very passionate about astronomy, photography, filming, and observation and documentation. These are the reasons why I got involved with Globe, and I am volunteering to be a Globe student blogger. As I said, I love to observe stars, clouds, the sky, whatever, and I like to document for other people to enjoy it and see it. In fact, I used to have an Instagram account where I would post different edits I made with different apps on my phone, and it was quite successful and I really like doing it, and I still do it sometimes. I really hope I can be a Globe student blogger. I really like to do it, and I do it with a lot of passion and effort. Thank you, Globe, for the opportunity and for listening to me or about me, and that's it.
Hi, my name is Christine and I'm coming to you from California, United States. Here in Southern California, I'm so fortunate to be living in a community where I am able to step out and enjoy the environment around me. As you could probably tell, I am outside. I am actually here at my local regional park for my city. And just by this park alone, there is so much to offer. Whenever I want to take a nice hike, there are multiple hiking trails, all different distances to fit different preferences. Whenever I want to have a picnic, there is so much land to work with. And whenever I want to come out and just enjoy nature, there is a high diversity in different types of trees, flowers, and the occasional squirrel to look at. What I also love about my community is that I can take a nice, short, and safe walk. Because let's be honest, quarantine has got a lot of us isolated at home, so it's a great way to just once in a while just step outside and enjoy the breeze and the sunlight. If you're in my city and want to explore something different but not in this area alone, definitely go ahead and drive about 40 to 60 minutes towards the coast and you are likely to find about 4 different beaches. 4, maybe even more. Beaches are the classic Californian brochure cover advertisements, and I would not blame them. There's so many different types of beaches. Beaches made for surfers, skaters, fishers, tanners, and if you're at the right location, even bonfires. However, if I'm not feeling to be too active at the beaches, I can also find a way to enjoy the marine life. There are plenty of beaches here that offer different sightseeing, which include dolphins, whales, seals, and there are some that are common for stingrays, although I would not recommend going in the water in that case. In terms of the climate here in California, especially here in Southern California, we are known as sunny Southern California. Sunny most of the time, we love the mid-70s weather, and it doesn't typically change too often. However, we did experience, especially in my city, and a couple of others as well, we did have hail once this year. But besides that, there is so much to appreciate about my local community. By learning how to care for my community and the environment around me, I hope to also do the same for others. But thank you so much for watching. I appreciate you.
Are we ready?
Yes, Lim.
Yes.
Yes.
Okay. I have put in the chat my email. I do answer email a lot, and that's a very good way to get in touch with me. I've also put the link to all of these activities and adaptations and extensions. And if you have questions about them, please feel free to ask. Oh, one thing I wanted to say about soils, when you're doing soil characterization and you do a soil core, you only have to do it once. This is not once every 3 months, once every week. You do one. And so that's really fun for the kids to compare different sites by a stream bank, in a prairie, in a hilly area, and their school. If they compare the soils, it's really interesting and lots of good questions come up. So I really believe that we should be much more responsible to K-4, because we know that when students are young, especially in kindergarten through 2nd grade, they are just like sponges, learning anything and everything we can tell them. And if we get them interested in the environment and in science study, they will carry that with them throughout the rest of their lives and become lifelong learners. There are 7 books for Elementary Globe. What in the world is happening to our climate? What's up in the atmosphere? Do you know that clouds have names? All about Earth, the mystery of the missing hummingbirds, the discoveries at Willow Creek, and the scoop on soils. We have a 3rd grade through 5th grade Padlet that uses the storybooks and then lists materials that go with them. So this link, you will have this in the folder that I've sent you in my Google Docs. You will have this PowerPoint and can locate these things I'm talking about. And I'm not going to take time to go to these links right now. Under Do You Know That Clouds Have Names? There are several activities: Cloud Fun, Cloudscape, to spread or not to spread. And then there are a couple of coloring pages also that are listed there. I have added some more things, and I want to show you one of the activities that I've, I'm not being able to, anyway, I'm sorry, but the cloud song, I have a cloud song and then cloud pictures that go with the storybook, and I have made a flip book. And so what you do, and this flip book is there, what you do is, you may have seen these before or used these before. You show the page to the students, and on the back is what you read. And so then the next page, this is the picture the kids see, and this is what you are reading, and instructions. I have this Clouds and Cloud song. It's a song, but then pictures of cirrus, cumulus, and stratus. This would be for young students. I've changed the cloud book up a little bit so that it's interactive. So when I'm reading certain pages, the students are doing certain things. And this activity, I think you'll like. There are other things, this any old thermometer, that has to do with, why do we follow directions? Why do we use certain materials? It's the idea of, you have all kinds of thermometers. Some are broken, some are not the right kind, maybe meat thermometers, and thermometers that you can't read, and max min thermometers that you don't know how to read. And it's an activity that shows that we can't just use any old thermometer, because they come in, they go outside, they take measurements, they come in, and the measurements are just all over the chart that we would be using. So we need to make sure that we are using proper thermometers and proper, not just thermometers, but proper instruments. This one called Solar Mitts, and for some reason this is not, these are not, there it is. Oh, I don't know what's wrong. It was linked a while ago. Solar Mitts, students take pieces of paper, white and black, they tape it here, they tape it here, and they use the paper like a mitten. So they have one white one and one black one, and they go outside. It is amazing in the sunlight how quickly this one stays cool and the black one stays, gets hot very quickly. And if you need to talk to kids about solar energy and the sun's output, I had a student put the black one here and the white one here, and he was just, he couldn't believe the difference in temperature. We've put thermometers up inside the mitts to see the differences in the temperature as if I had not one activity to show you, this would be one that is just really phenomenal. And I think you'll like it. NASA Langley has also done some other types of things with clouds. And this UCAR rain measurements tell a story. This one would be for 4th and 5th grade students, because it's a little bit older. You have to read a little bit more, but those have to do with some things. And all of these activities are in that folder that I'm not able to access right now. What in the world is happening to our weather or our climate? There are 3 activities. Weather adds up to climate. And this is what the bar looks like. You have the different types. This is sunny, partly cloudy, cloudy, foggy. So the students then, this is the base. And then every day they add a block for 1 month to see how many days were cloudy, how many days were sunny, how many days. And this is a really good way. It makes a bar graph with the different, and you don't have to use these. You could use, if you have Legos, the big ones are expensive, but you could do this on the wall. Put these on the wall and then use sticky notes or pieces of paper that are squares that are cut, and the kids could see it then as a class chart. So don't think that you have to do it this way. There are many other ways that you can do the same thing. And then the kids also are keeping a record. The students are also keeping a record in their journals, and it's just a really good way. So weather adds up to climate. Seashores on the Move is another one, especially for any of your countries that are on the coast. And then we're all part of the solution. It has to do with what we as individuals can do to help. Once again, they're color pages. The sensory weather game, I made a game out of these little squares. So I made a game, and I'm sorry I can't get to it right now, but these are the different types of things that are in those folders that you have access to. What's up in the atmosphere? Exploring colors. Why not so blue? Sky observers. See the light, and up in the air. This one is uses prisms for see the light to, and this is where if you're using any kind of prisms or just looking at the energy that comes from the sun, this is a really good book for that. I made some things for younger students. You know the CDs that we don't use anymore? Okay, if you turn, you've got the side with the label, and then you've got the other side that acts like a rainbow. It breaks up light. And the CD rainbow, we have them hanging from the ceiling, and the sunlight catches and makes rainbows with that. So it's a good way to use CDs that you don't use anymore. This EMS headband is a headband that students wear that goes from gamma rays, X-rays, visible light is right in the middle. And so it takes the whole electromagnetic spectrum, and the students can make a headband out of it. And then I have a song that I made up called The Spectrum of the Sun. And it goes along with the headband. So that's kind of fun. The Mystery of the Missing Hummingbirds, all year long, colors of the season, honing in on hummingbirds. I really like this colors of the seasons. It's a really, really good one. And one of the things that I like about the Missing Hummingbirds is it uses Costa Rica and Pennsylvania. And so we've got two countries that are involved in hummingbird migration. And the question of where did the hummingbirds go? In Pennsylvania, and then they contact a Globe school in Costa Rica, and they find out where the hummingbirds went. I created a flip book to go along with this, and this is a part of one of the pages blown up. I enlarged it, and all of this is in that folder. And then I created a student sheet so that they, as the teacher is reading the story, the students can mark the temperatures of the two different countries, individual Pennsylvania. And then I have this so the students can follow along, and they are doing something while the teacher is reading the story. I wanted some kind of interactive for the students to be doing. So that's The Mystery of the Missing Hummingbird. And here's the thermometer data sheet for the flip book. That's this one. So it's right here. This engagement with big picture and zoomed in view, that's really fun. I also have put some other things in here. And once again, when you get into the folder, these links will work and take you to these particular activities. Discoveries at Willow Creek, one of the things that I liked about this, magnify that, and water wonders. And I have an extension. I'm sure you've seen these pictures in the water wonders. They're one of the activities. If you look really closely at all these macro invertebrates, all these, they are all basically big. There is information here, but it makes it look like all these little water critters are big. They're not. Look at the size of them, of some of them. Some of them are pretty big, but some of them are also really tiny. So I put pictures together, and if the students use this information right here and a ruler, they have to figure out which is which. And so instead of using this, I have real pictures of what the critters look like. And then the students have to figure out which one is the water boatman, which one is the whirligig beetle. And they use this information to figure out which is which on this page. So that one is in Water Wonders and the extension. So here's the, oh, and another thing too is there is a sheet that I made up, because when the students go to Willow Creek in the fall, it looks one way. And when they go back in the spring, it looks totally different. So I made a sheet for them to record the differences that they see. So the scoop on soils, getting to know soils. I also have a flip book. And in the flip book, I made, in some cases, the wording a little shorter, so it's easier to read. But this, once again, is a flip book, and it has a picture on the front, and it has what you say on the back when you're looking at it. So I created a journaling sheet for the kids to make this. As the students in the book are recording the data, I made a sheet. So the students, well, let me find the end one. The students are recording all the soils that they found. Here are what the students recorded in the different places they went: the meadow, the forest, and the garden. And so I created a sheet for the kids in the class to follow along as they're talking about each place they visited. The students can add in what the students saw. So here's where that sand, silt, and clay song is. Here's the flip book, and there's the journal page. I do recommend the Soil in My Backyard learning activity that's in the Globe pages. Just passing through. This is how I put together just passing through. This is enough for a group of 4 students. I've got everything I need in here except the soil. I've got the filters. I have the filters that I use from a liter bottle. And this is just window screen and taped on there. You could also use a hose, women's hose, or cheesecloth. You could use anything like that. But here's where the soil would go. And then you would have a container that the water drains into, and then you measure it to see how much soil. And so you can do it this way if you want to, in a 100 milliliter tube, or you can use it in a container, it doesn't matter. So the soil would go in here, water would go in, and then you're seeing how much water. You have 100 milliliters of water, you pour it into this container, and then you see how much water filters through. There is a lesson activity in the book, in the Globe pages, that has a beginner activity and also a more advanced activity that you can do with that. Why do we study soils and the earth apple? This is the one I turned into a PowerPoint, and you have access to that. A field of view, there is a Jamboard field of view that you might want to look at. Getting to know soils, that's where we're looking at each other's soils and going through, and then soil characterization and texture by field is what we did today. All about Earth, our world on stage. This Earth system play is really good for students to perform. I've created a story in the flip book. If you use these, here's the flip book, and there are characters in here that are acting out. This one. Here's one of the characters. I've taken this and all the other characters and made them into stick figures. So you can cut this out, tape a stick to the back of it, and use them as characters if you want to read the story while the students are pretending to be the characters, or they can do it themselves. The Earth System song I put on one page instead of the 2 pages in the storybook, so it can print out and students can read it. The observation walk, sometimes we take students out and we tell them we want them to make observations, but they don't know how to do that. And so this observation walk is a PowerPoint that you go through and help them see what they're looking for as far as the connections between atmosphere and hydrosphere, hydrosphere and pedosphere, pedosphere and biosphere. So how all those interconnections are made. And then you can use this Jamboard. You can use this Jamboard to look at this and say, all right, they could stick a little sticky. There are stickers here that you add in, and you type, what do you see? Well, this person saw mountains with snow, so that would be geosphere and hydrosphere. You see the ground, and so you see biosphere on geosphere. You see the snow on the mountains, so atmosphere would have deposited the snow, and it's on geosphere. Geosphere to me is very important. So here, what do you see? What interactions between atmosphere, biosphere, geosphere, and pedosphere? Once again, here again, what interactions do you see? Atmosphere on geosphere, the clouds are shading this area and this area. There are biosphere and geosphere, and the atmosphere is there as well. Interactions again. So that's just a connections Jamboard that give the students a chance. You could even put up one of these pictures and just have students journal in it. This Padlet, this takes the Earth system science and goes from the storybook all the way through to the Earth system posters that are used by older students. And this is the cloud song. Look at the sky and what do you see? What do you see? What do you see? Look at the sky and what do you see? Are there any clouds? If the cloud is puffy and white, puffy and white, puffy and white. If the cloud is puffy and white, then it's cumulus. And so this is the starting point for clouds with younger students. Here are directions about what to do. And then here are the pictures I was telling you about. So this is enough for a classroom to do. And there's several activities in here. Those are stratus. And make sure kids know that fog is a stratus cloud, because I had a teacher once tell me it was a form of precipitation. And that wasn't right. So anyway, there's lots of information in here. Observation and measurement is very important. There's an observation. Oops, I can't pull that up. Observation, make an observation. Observation, tell me what you see. Is it flattened? Is it soft? Is it big and is it rough? I don't know. Anyway, that's a song that goes along with this. Magnifier, finding tools for science. They're little bitty tiny pictures and the kids have to use the handheld magnifier to see what they are and match them with bigger pictures. And then they choose a couple of the things that they have found and they write a story about how they would use them in a science classroom. There are data cube guides that MyNASA Data has. And these are a lot of fun for 3rd grade through 5th grade. This learning activity that's in the Globe book on field view of soils. And also there's an activity on plant growth observations. I've made up some games and this Jamboard, as I said, on Earth System Science is there. So there's lots and lots of information for you. This is the link. And these are all the different, that was the link I gave you. There's stuff on aerosols. There's stuff on climate. And even these have more. You'll get lost in these because there's lots of activities. Oh, this is the headband. This is what the headband looks like. So this goes in the middle of the forehead, and then the waves go on one side. The kids cut this out and put it together. And if you do it in black and white, that's fine, and then have the kids color it. I was going to try to show you the mitts, the solar mitts. Well, I don't want to take time to find them. But anyway, the solar mitts I definitely would recommend. Pedosphere. Here's learning activities from Globe, just passing through. Why do we study soils? There are PDFs in here, getting to know soils. Protocols, there are several protocols that younger students can do. Storybook and activities, all of these. Here's the flip book that I was talking about, and then the journal pages. Observation and measurement. Oh, this zoomed in engagement. So let me see if I can go to the next page. All right, so look at this. This is zoomed in. There is an activity in the books on this, but what do you see here? This would be a zoomed out. This would be the big view. And then you ask the students after they've told you after they've given you answers about what they see, then ask them, did you see this? This is the zoomed in version. Did you see this? And so getting them, here's the song. Is it rough or is it smooth? Is it big or is it small? Rough or smooth, big or small? Oh, observation, make an observation. Observation, tell me what you see. And then this is a card that they can use. They cut out this little part in the middle and they use just that part to zoom in to see something that they might not have seen when they're looking at the big picture. So I like that because it gives the kids a chance to think about what they're looking at. And I also have in here metric rulers. If you print these on paper or if you print them on transparency, students can use these. I also like giving these out to parents who may not have rulers. And this is something that they can use at home. So pedosphere, then here are all the different types of things. This is that earth apple. And here's all the information there about making the strip as well as the, and here's the PowerPoint. This is that pedosphere session that I just did. And at the end, it has the PowerPoint with the instructions on how to let me get to the earth apple. This is the earth apple. So you have access to this and the instructions. I use this when I'm giving instructions to people, and I would not go through it as quickly as I have gone through it with you, but this would be something that the students are doing while I'm talking about it, and they have this in front of them. So that's that. Sand, silt, and clay. Here's that song that I made up. And so there's lots and lots of information here. Here's the teacher implementation guide that Globe has. Any of the protocols I have in here. So data explorations, all kinds of, this would be something that 4th and 5th grade, 5th grade would do. I really like the one about Benin, monsoons and health. This one is a really good one, and 5th graders could do that one easily. So I kind of shortened my time here so that if you had any questions, I've given you this link right here. It was in the chat and my email is in the chat. Why don't we open it up? And if you have questions, guys, why don't we unmute everybody? And if they have questions, they're more than welcome to ask them now. We'll take a few minutes and then I'm pretty much done. I just wanted everyone to be able to see there's a multitude of kindergarten through 4th grade, 5th grade materials that are available to you.
Lynn, if you want to stop sharing your screen, maybe if someone has a question, they can turn on the camera and the microphone and just answer to you.
Yes.
Cualquiera que tenga una pregunta, una consulta, algo para hacerle a Lynn, directamente prendan el micrófono, la cámara y se lo preguntan directamente. O mismo si quieren compartir experiencias de haber trabajado con alguna de estas actividades en clase. Andrea puso en el chat que varios de los libritos de Globe Elementary están en español. Es así, tienen que ir directamente a la página de Globe y ahí los ven, los pueden descargar en inglés o en español y hay en otros idiomas también.
Yes, that is correct. Right. And Claudia found the PDF of soil color and she has the link in the chat. There is a PDF of soil color. Be careful though when you're printing it because sometimes a printer will change the color.
Yes.
So just be careful.
No sé si había preguntas en el chat, yo vi varios comentarios, Paz, no sé si vos anotaste algo. Ahí.
No, no había
Donovan, I think, had a question earlier.
Sí. Ahora me fijo, no, pero por lo que estuve viendo.
I'm looking. It was a question about soils.
Yes, can you hear me?
Yes.
Okay. No, that was a question about soil, but I think so. Can I ask the question?
Yes.
Okay. No, actually, it's not about a question, but because you said something about berries that they can grow on acidic ground.
It broke up and I'm not sure about your question.
You said that the berries, some type of berries, fruits, can grow on acidic ground, acidic soil.
Yes. I was talking about hydrangeas. That is a flower. And in acidic soil, it will be one color. In basic soil, it will be another color. So blue or pink. And the colors of blue and pink can show up. Oh, and you're talking about cranberries. Cranberries, we have
cranberries. Yeah.
Cranberries, yeah. They grow in more acidic soil.
I just threw berries on my. Okay.
Yeah.
Yeah, no, because I live in a place. Sorry. Yeah, I live in a village where our soil is very poor. It's much sand, so we cannot grow vegetable on our soil. So for some plants and trees, they grow very well.
Yes.
For example, mangoes grow very good, and the people in the village they grow cassava. I don't know how to pronounce it in English, but cassava they grow, and other things like olive that grows very well, and also the cashew. So I think the topic what you were talking about soil, I think it's very important because you need to understand how the soil works.
Right.
And for that, I thank you so that I can understand much more. Not every place where you live, you cannot plant everything. For example, vegetables. So my place where I live right now, I cannot plant vegetables. But you can, but you have to try it. For the rest, like say for coconuts, mangoes, what you can plant, and it grows very well. That was actually my question or
Good.
answer.
Good.
Thank you.
Our soil is very rocky, and we cannot grow. Where I live in Northwest Arkansas, we cannot grow vegetables here. No. Strawberries grow very well in sandy soil because they need lots of ability to filter, and the water has to drain very quickly. And it's really interesting. I am a geologist, and I have studied soils. And to me, the rock type determines, and the climate determines the soil. The soil determines the vegetation, and then the vegetation brings in the animals. And so, but it all starts with soils. Anna, you had a question?
Sí, con respecto a cuánto de profundidad a veces se enseña, me gustó mucho el gráfico para los niños de jardín, cómo hacerlo con los Lego. Aquí a veces no es muy común que se hable de gráficos en niños tan pequeños. ¿Podrías contar algo más de esas experiencias en jardín y primaria, y primeros años de primaria?
Yes, on using the wall and using pieces of paper and sticking them on the wall, like, okay, today it's sunny. We put a sticker there, and it might be just the sun picture, not the words, or maybe sunny underneath with the picture.
Yes.
You have it on the wall, and then they see it grow every day. That's a bar graph. They may not, you may not call it a bar graph, but they're then at the end of the month, they're looking at it and they're standing back and they can count 1, 2, 3, 4, 5, 6. You know, they're using their skills. And then you can say, how many days were sunny? How many days were cloudy? How many days was it raining? So you're bringing their attention to what they've created. And that's what GLOBE is all about, is the students collecting data and then talking about it. And so it's...
Sí, que procesen datos,
Yes.
aunque sean pequeños. Okay.
Yes. Right. Yes. And if you start very young with something they can do, then as they get older, they've got the concept in their brain about what to do.
Thanks.
You're welcome. Andrea?
Yeah, I wanted to clarify, Lynn, because we don't have the same education model as you have in North America. Which level or which ages do you mean when you say Key 4?
Oh, K4 would be, our students start 5 years in kindergarten, they're 5. So it would be 5, 6, 7, 8, 9 to 10. So 5 to 10, 5 to 9 years of age. Yeah.
Ah, okay, thank you. And I wanted to share with you that some days ago, we made some visits to the schools in Uruguay, and it was a coincidence that I applied the activity of the photographs to identify clouds. it was very nice because the students love to guess which one is it, and it's like a competition, a great competition between them to get to know which one it's the right one.
Right. And I've tried to make some of the lessons simpler, like kindergarten, 5-year-olds and 6-year-olds do not have to know the 10 cloud types that we use in older grades. But if they understand cirrus, cumulus, and stratus, that's the beginning. And so we just want to build on what they're learning at a very young age because they are interested. They want to know. And you're right, there's competition that they get into.
Yeah, of course.
Yeah.
I used my own photographs, but it's the same idea that you had.
Yeah.
I saw it. And
well,
thank you for all the things we learned all the time from you because you're great.
Oh, thank you. Well, I if it's not fun for me, I'm not going to share it with others because I like doing fun things that are interesting and that students are going to want to do. So that's the reason I made some of these sheets to go along with the storybooks so that they could do stuff.
Thank you.
You're welcome. I'm sorry I don't speak Spanish. I did learn when I was 10. Me gusta la leche, me gusta café, pero más me gusta los ojos de usted. That's and cerveza. I know cerveza.
Great.
And el baño. I know those.
You know, principal word.
So if there are no other questions, you have my email, you have the link, and those files are yours to use or not, but they're there for you to use. So please.
Seguramente, Lynn, con tu permiso de que podamos usar esas actividades, vamos a traducirlas al español, varias de ellas, para que muchos más maestros y coordinadores las puedan usar, porque son realmente súper interesantes y como bien marcabas vos, son divertidas de hacer con los chicos, entonces eso hace que se comprometan más con su trabajo y se entusiasmen más.
Good. Bueno.
Perdón, y quería comentar, Mariana, viste que habíamos hablado el otro día de la importancia de hacer la actividad de aprendizaje antes de los protocolos, fundamental.
Y sí, para poder aprovechar.
Oftentimes the learning activities make sense of the protocols as to why you're doing them.
Sí, yes, totally true, Lynn. And sometimes some teachers, they learn the protocol, but they don't know how to implement it in the classroom. So all the learning activities are really important. It's a key role in all the GLOBE implementation parts.
Yes, I really like the just passing through activity with soils because it's very simple, but there's a lot more to it as you talk about it. And there are data sheets that the kids are filling out that are very simple. And yet there's a lot going on there in that one activity.
Yes, and if you want, you can go deeper and deeper. And if not, and if you don't have time of your students are too young, you can just keep in the surface.
Yes. Ani, did you have another question?
Yo vi algo en el chat, no sé qué era.
No, quería hacer un comentario.
Ah.
Los niños pequeños no tienen tanta vergüenza para hablar en público, para exponer. O sea, aprovechenlo. Muchas veces en la adolescencia ya como que hay ciertos temores, un poco de vergüenza. En los primeros años de la primaria son muy auténticos y aprenden un tema y lo explican perfecto.
Sí.
O sea, no tengan miedo los que tienen niños pequeños porque realmente son bárbaros. En general aprenden muy bien y se expresan muy bien ante cualquier cosa que tengan que explicar.
And measurement and observation are key to everything that they do. They have to look, but they have to understand. And observation, if we help them observe, it's going to open up their minds.
No sé si hay alguna pregunta más, algún comentario para Lynn.
Yo solamente quería hacer un comentario. As Lynn did in her presentation, her great presentation, I think that is too important also to relate all these activities with the curriculum, because it will make sense for students and for teachers how to implement GLOW program. And also not to give only the protocols, also explain why there are the importance of that about atmosphere, pedosphere, or any other biosphere, any other investigation area. That is so important.
It is important.
Vos estabas por decir algo, me parece. No sé si era que ibas a leer algún comentario del chat.
No, justo iba a avisar que Marta había levantado la mano y que hay muchos mensajes en el chat en español, Lynn, pero diciéndote gracias por tu entusiasmo, que muchos profesores se vieron inspirados por tu entusiasmo para aplicarlo después al aula. Y muchas gracias por tus presentaciones y etcétera. Así que aprovecho para que te los traduzcamos y que sepas que de verdad transmitiste ese entusiasmo por enseñar.
Email me. I think Claudia has a question.
No, yo simplemente quería valorar todas estas actividades que tienen un carácter interdisciplinario, que uno puede relacionar las ciencias naturales con la educación tecnológica, con la matemática, con la lengua. Realmente, como habitualmente uno trabaja en la escuela primaria, implementar ese tipo de metodología en la educación de secundaria también. Me parece muy bien porque Lynn en todo fue mostrando ese tipo de mirada, una mirada multidisciplinar, que yo creo que es lo que se debería hacer en general en toda la educación. Solamente era eso, valorar, porque me parece muy importante.
You are right. Carolina?
Muchas gracias, Lynn, por toda la información que nos has dado. Creo que nos quedamos todos muy motivados. Y a mí sí me queda una duda. ¿Cuál es tu canción favorita de las que nos has, las que has puesto en los materiales?
My favorite.
Muchas gracias.
Observation, make an observation. Observation, tell me what you see.
We are seeing your dog.
Oh, thank you all for coming.
No, gracias Lynn, realmente me sumo a las palabras de Andrea, que los que tuvimos la oportunidad de estar en varias ocasiones con vos siempre aprendimos algo nuevo. Sos realmente muy generosa con todos tus conocimientos sobre GLOB, sos una persona muy amigable y eso es realmente el espíritu del programa, ¿no? Entonces sos una gran representante del programa GLOB. Te agradezco infinitamente el tiempo que dedicaste a preparar este taller y esta presentación, y a tu generosidad en compartir todas las actividades y todos los materiales que van a ser súper importantes para todos los profesores de la región. Nosotros nos comprometemos a traducir gran parte de ellos para que muchos los puedan usar y aprovechar. Y bueno, seguramente te seguiremos convocando para algunas otras actividades porque sabemos que transmitís mucho entusiasmo y sos muy clara en tus explicaciones, que eso también es súper importante con estos temas.
I give you all hugs.
Well, thank you so much.
I miss you. I miss seeing you.
We too.
Stay safe and have a happy, merry, wonderful rest of the year. Be healthy and email me.
Thank you so much. We hope to see you in person next year.
Yes, I hope so as well. And
Okay.
I'm going to leave now.
Okay, thank you.
Very much.
Bye-bye.
Bye-bye.
Bye, thank you.
You're welcome.
Bueno, los esperamos a todos mañana para el último día de nuestra querida reunión regional. Un gusto compartir hoy con ustedes.
Gracias, Paz. Gracias, Mariana. Un gusto verlas a todas. Thank you, Mariana and Paz.
Mañana.
Seeing you, everyone.
Gracias, nos vemos mañana.
Hasta mañana.
Muchas
Muchas gracias.
Hasta mañana.
Hasta mañana.
Adios, everyone.
Ahorita